Okay, hello guys. I'm gonna record and then so we're gonna talk about cofactors. Okay, so let me open a new page. Let me share my screen here. Okay, so here, so we're gonna do. See what is this? Oh, we're gonna do inverse of a matrix using cofactors. This is an application of determinants, okay? This is an alternative way to do, let me make sure I'm sharing my screen. Yeah. This is an alternative way to find the inverse matrix. Okay? Okay, so we already used this idea a little bit. So if you have a, let's remember or let's define something called minor matrices. Okay. So if you have a matrix, let's say A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So we define the minor matrices, and we really kind of talk about this. We're gonna, it's kind of, maybe I'm gonna call it with another, I'm gonna call it, I'm gonna call it M, okay? So we'll call it, so if you eliminate the first row and the first column, you got this matrix over here, okay? That's called the minor matrix, and we are gonna call it N11. So the matrix is A22, A23, A32, and A33, okay? And now if we change, and now we choose this one, we call this one, we're gonna call it N12. So that one is this guy with this guy. So this is A, this is A21. A21 with A31, and then A23 with A33. Okay. And then the other minor, we're gonna use, or we can define many minors, but another minor is this one, right? And this is called, so basically this guy that I eliminate, this guy, the intersection of two, that's the name of the minor, right? So this is N13, and this is A21, A22, A31, and A32. Okay. So we already saw, so we defined the determinant in these terms, right? So we already saw that the determinant, let's say this matrix is A, the determinant of the matrix A, that could be written as A11 times the determinant of n11, right? This kind of, I'm giving you kind of a new notation, but we did this in the previous talk. And then the other one is, we said there was minus, right? A12, determinant of n12. And then finally, plus A13 times the determinant of n13. So that's how we, last time, that's how we find it. I'm just saying, these guys are called minor matrices. Okay, and they're gonna be important. Okay, so it's gonna be important because look at this. So just like define n13, I can define something. I can define another minor matrix, and I can define, let's say I want to define the one that comes from here and with this one. Okay, so I'm gonna call that one. So what do you think? I'm gonna call it M22, right? So the matrix is gonna be A11, A13, A31, and then A33. Okay, so that's, so you can get N11, M12, N13, N21, M22, N23, N31, N32, N33. Okay, and that's gonna be the secret of how we're gonna find the inverse matrix of A. So in general, so we define the cofactor Aij as this is the, we're gonna call it Cij, and it's gonna be the determinant of the Mij, and then times -1 to the I plus j. Okay, so that's why we chose here plus minus plus, because 1 plus 1 is -1 to the 1 plus 1 is -1 to the 2 is positive, so that's positive. This is -1 to the 1 plus 2, -1 to the 3 is negative, and then -1 to the 1 plus 3 is -1 to the 4, that's positive 1. So that's plus -1, that's why it's oscillating. Okay, so I can write this determinant as using this fancy, for now, looks unnecessary definition, but the determinant of A can be written as A11 times C11 plus A12 times C12 plus A13 times C13. This is just what we had done. Is just another way to do what we had done. I mean, no, another way. Just, we're just changing the names of something we know how to do. Okay, why this is good? Because look at, for example, consider the general case. So this notation allows me to extend my definition of the determinant to many dimensions. So if A is A11, A12, etc., until A1n. So my matrix can be dimension 100 by 100. And then this goes down, and this is AN1, NA2, and this is A and N. Okay, so the determinant of A is gonna be A11 times the cofactor, 1, 1, plus A12 times the cofactor, 1, 2, plus A1n cofactor of 1n of A1n. So, and we know that's going to be plus, minus, plus, minus, plus, because that's part of the cofactor of this formula. Okay. So now, I mean, I'm not going to do that, but I could give you a matrix 4 by 4 and ask you to find the determinant of that. And then you're going to have to use this long formula. Okay. So this is good because I can extend my definition of determinant to several dimensions. Okay. Not just 3 by 3, and now I'm going to do it 100 by 100. So you can implement this in a computer. Okay. Okay, so what I'm going to do now is use this to define the inverse of a matrix. So next, let's use cofactors to find a inverse. Okay. So let me see here. Let me stop this for a second. Okay, so we're gonna define the cofactor matrix definition. Definition cofactor matrix. So that's gonna be C, and then you're just gonna put all the C11, C12, and well, let's say, well, you can put all the C1 and all of them, right? This is the CN1, CNN. Of course, if our matrix is 3 by 3, so this is just C11, C12, C13, C21, C22, C23, then C31, C32, C33. Okay. This is when it's n by n. And then we define the adjoint matrix. Adjoint matrix. And the adjoint matrix and use it adjoint of A is C transpose. And this is C11, C12, and let's say C13, so people don't get scared with the one ends. And then, so this is C. C transpose is change the rows by columns. So this row becomes a column. Okay. And then C21, C22, C23, and then C31, C32, then C33. Okay. That's the adjoint matrix. Finally, this is a theorem. The A inverse is 1 over the determinant of A times the adjoint of A. Okay, that's the inverse matrix. So to find the inverse matrix, we need to find the determinant, and then given A, find the cofactor 1, 1, cofactor 2, 1, cofactor 3, 1, and put it in this form. So this is the adjoint matrix of A, okay? Let's put it like this. Okay, for clarity. Okay, so let's make a test if this theorem is true or not. I mean, it's possible to prove it, but you know, let's see. Maybe next week it will be nice to show you a proof of this. But for today, let's test it with an example that we are very familiar with. So let's put A, B, C, and D. Okay, this is A. This is our matrix A. And we know, right? And we prove it using the Gaussian elimination method. Remember, we prove it that the inverse matrix of A is AD minus BC. This DA, and then minus B minus C. That's what we proved, right? Well, we proved using Gaussian elimination method. So let's do it finding that joint, right? So by definition, or not by definition, by the theorem, this is the theorem, A inverse equals the 1 over the determinant of A, and then times the adjoint of A, right? So the determinant of A is 1 over AD minus BC times the adjoint of A. So now we need to find the adjoint of A. So what is the adjoint of A? The adjoint of A, following here our definition over here, where is it? Is this. Is the transpose of C. Okay, so is C transpose. So if I find is the transpose of C11, C12, C21, C22. And what is C11? C11 is, so over here is the definition. Here. C11, so let's write it here. C11 is minus 1 to the 1 plus 1 times the determinant of N11. Okay, so let's do it over here. So C11 is minus 1, 1 plus 1 times the determinant of N11. So what is N11? Look, this is easy. This is, oh, I need to find A. So I need to write A. A is A, B, C, and D. So determinant of N11, right? Let's put here N11 here. But so what is it? So N11 is this position. So here is, I just got a number, and the determinant of the number is just the same number. So is minus 1, 1, 1, minus 1 to the square, determinant of N11, that's just D. And then minus 1 squared is 1, and the determinant of D is D. So this is just D. So here we put D, and then we're gonna do transpose. So what is C12? C12 is minus 1, 1 plus 2, determinant of N12. And what is N12? N12 is this one. This is minus 1 cube. And the determinant n1, 2 is the determinant of b. And this is minus b. So this guy is minus b. So C13, no, C21. C21 is minus 1, 2 plus 1. This is the determinant of M21. And this is minus 1 cube. And then the determinant of 3 1. So 2 1. So is it determinant? Oh no, sorry, I did it wrong. Determinant of 2 1. So I just got 1 and 2. Oh, I did wrong the other one. Sorry. Let's see. So this is the terminal 1, 2 is row 1, column 2. So I got C. Oh, sorry. This is C. And the other one was D. Yeah. The other one is 1, 2. So that's minus C. And this is 2, 1. So I was getting a sign here in my iPad about battery, and I got disconcentrated. So this is 2, 1. So this is row 2, column 1. C minus 2, D minus 2. And this is determinant of A. This is minus A. Finally, C22. So, okay, so I need to change this guy. D minus C. And the other one is minus A. And the other one is C22. C22. C22 is A. So we got minus 1, 2 plus 2, determinant M22. And then I get minus 1 to the 4, determinant of ¿Cuál? Wait. 2, 2 is A. So this is A. And this one is 2, 1. Sorry, this is 2, 1. So row 2, column 1. Row 2, column 1. Row 2, column 1, yeah. Row 2, column 1. So this one is minus B, right? Sorry, I'm trying to go fast and then, silly mistakes. Okay, so let's check. 2, 1, row 2, column 1 is that one. Row 2, column 2 is A. Yeah, so that looks good. This do D minus C, then this is minus B, and then this is A. Okay, so you find the transpose of this is gonna be D minus C, I minus B, A. Okay. So with that, now we can apply our formula. this is 1 over AD minus BC times the adjoint, that is this one, D minus B minus CA. And look at they match, okay? That's what we did before with the other method. Okay? They're the same. Okay, so the method works. Good. Okay, so now what I'm gonna do is find the inverse of a matrix 3 by 3. Okay. And we're gonna use the adjacent. Okay. The adjoint. I don't know what it's adjacent. Adjoint. So let's do this example, and then with this you can solve your homework example. So find the inverse matrix of A equals 3, 1, 0 minus 1, 2, 1, 0 minus 1, 2. Okay. So yeah, I don't, I don't mind to make mistakes in the lecture because I think you learn more. Okay. I could read the slides and I don't make mistakes, right? But you don't. Reading the slides, I mean, I don't think it's too much the point. I mean, the point is that you see how it's done in reality, because these kind of the mistakes are the ones that you're gonna make. Okay, so it's good that you say, oh, because those are very common mistakes. You get distracted for a second, that's the kind of mistake we make. Okay, so find the inverse of the matrix. So again, we need the A inverse is gonna be 1 over the determinant of A, and then the adjoint of A. But we're gonna save some time here because we use cofactors to find the determinant, and then we're gonna use cofactors to find the others. So, but it still is long. Find the inverse of a matrix is it's always long process, but it's extremely useful. This is fundamental. Okay, so you need to suffer this, or later you don't have to do it all your life. You suffer right now, the later you don't have to do it all your life. So the determinant of A, we said that this is gonna be A11 times C11 plus A12 times C12, and then plus A13 times C13. Okay. So it's gonna be nice because thanks to these zeros, those guys are gonna be zeros. So the calculations are not as bad as could be. So what is C11? So C11 is, as we saw, this is position minus 1, 1 plus 1, and the determinant of the matrix. Oh, I just like to put it sometimes this notation, it's kind of faster. Of 2, 1 minus 1, 2. So that will give me positive, and that will give me 4 minus times minus times minus is minus 1, that will be plus 1, that will be me 5. You see, it's not that bad. The next one is C12, and this is minus 1, 1 plus 2, minus 1, 0, 1, 2, and this is minus, and then give me minus 2, minus 0, so it give me 2. Yeah, that's 1, 2. Then I'm gonna do C1, 3. Minus 1, 1 plus 3. And then I'm gonna erase this one. And then I'm gonna have to choose the row 1, column 3. So that gives me a determinant of minus 1, 2, 0, minus 1. And that's minus 1 to the 4 is 1. So that'll give me minus 1 times minus 1 is 1. Minus 0 is, so it's just 1. C1, 3 is 1. And with that, we have enough to find the determinant. So the determinant is going to be A11. So A11 is 3. So it will give me 3 times the cofactor, that is 5. 3 times 5. Plus 2 times the, oh, sorry, plus 1. This is 1, right? This is 1. Times the cofactor, that is 2. Plus the last one is 0, so that's 0. So you don't have to do that one. 0 times anything is 0. So finally, I get 3 times 5 plus 2 is 17. So my determinant is 17. Okay. And I already have C11, C12, C13. So I keep going. But I'm going to have to write this matrix over here, so I don't have to go up and down. So 3, 3, 1, 0, minus 1, 2, 1, 0, minus 1, 2. Okay, so remember, you already have a homework for this, and also you'll have a quiz. Let me see, 3, 1, 0, minus 1, 2, 1, 0, minus 1. Okay, so we continue. So now we need to find C21, which is minus 1, 2 plus 1, and this is, oh, no, sorry. You see, those are the mistakes. So row 2, column 1. So my numbers are 1, 0, minus 1, 2. And then this is minus, and 1 times 2 is minus 2. Listo? Now we do the C21, we do C22. That's minus 1. And then C22 is this one. So we do 3, 0, 0, 2. It'll be minus 6. Is that right or not? Oh, no. Because I made 2, 2 is minus 1 to the 2 plus 2, right? So that's minus 1 to the 4, so it's plus. Okay? That's what we need to check all the time. Okay, so far we have 5, 2, 1, and C21 is minus 2, and C22 is 6. Yeah, okay. So next is nice because this one is a 0. This next one is C31. But this is a 0, so We don't need to waste time. This is just gonna be 0. Because it's 0 times the minor. So it's 0. So the next one is C for 1. So C for 1. Okay, what? C32. C32 is minus 1, 3 plus 2. And this is 3, 0, 0, 2. Minus 1, 3 plus 2. No, it's wrong, right? I'm doing 3, 2, so this is wrong. It's this one, right? Row 3, column 2. Sorry. I had to double check. So row 3, column 2, yeah. So that's going to be 3 minus 1, 0, and 1. This is minus. And then that's going to be times 3. Okay. So you see this, I could just read this and do this example in a minute. So this takes more time. But I think if you do it with me, this is very useful for you. So finally, C33. So let me do it here so I don't have to copy this. C33 is minus 1, 3 plus 3, and determinant of is 3, this is 3. So I do 3, 1, minus 1, 2. That's minus 1, 2. The 3 plus 3 is positive. This is 6 minus times minus plus 1, that's 7, no? Yeah. So C33 is 7. Okay. Finally. So what is my C? My C is called my cofactor matrix. Cofactor matrix. Okay. So my cofactor matrix is C11, C12, C13. So C11 is 5. C12 is 2. C13 is 1. C21 is minus 2. C22 is 6. Oh, I didn't find C23. Oh, C22 is 6. I didn't find C23. Oh. Okay, let's find C23. So C23 is C2, C3. So this will be minus 1 to the 2 plus 3. So that's minus 1 to the 5. And then 3, 1, 0, minus 1. So that will be minus 3 times minus 1 is minus 3. And minus, so 3 times minus 1 minus, so that will give me 3. So C23 is 3. Now C31 is 0. C32 is minus 3. And C33 is 7. This is all. I took it all from this that we calculate. So 5, 2, 1, minus 2, 6, minus 3, 3, 0, 3, minus 3, 7. Okay. Now, so remember, the inverse of A is 1 over the determinant of A times the adjoint remember A is 17, right? So we found it here, 17. That's my determinant. So this is 17, 1 over 17 times the adjoint. So the adjoint is, what is the adjoint? 8C transposed. That means 1 over 17, and I had to transpose C. So the rows becomes columns. So this row is going to become a column. So it's going to be 5, 2, 1, minus 2, 6, 3, then 0, minus 3, 7. And this is my A inverse. And we can check a few. I mean, we can do it by hand very fast. I mean, we're not going to do all of them, but we're going to check a few. So 3, 1, 0, minus 1, 2, 1, 0, minus 1, 2, times this, that is 5 17ths, minus 2 17ths, 0, 2 17ths, 6 17ths, minus 3 17ths, 1 17ths, 3 17ths, and 7 17ths. You multiply that, that gives you this guy times this guy. That guy has to give us 1. So 3 times 5 is 5 17ths is 15 17ths. 1 times, well, let's do it just 1. Just 5 17ths plus 2 17ths plus 0. That's 17 17ths. That's going to be 1, right? And so on. So let's check this one now. This one, so this position has to give us 1. So the diagonal has to give us 1, right? I mean, you do it, you can verify it yourself. It has to give you the identity. So if I do this one times this one, I'm gonna get the position 2, 2. That's supposed to be a 1. So minus 1 times minus 2 17ths is 2 17ths, plus 2 times 6 is 12. So 14 17ths plus 3 17ths, 17 17ths is 1. Okay. Let's do the last one over here. You can use calculators or something. For this, at some point, we already evaluate product of matrices. So you know how to multiply matrices, right? You can just use your calculators. So once we evaluate something, you can use your calculator, but not in the final, right? But in the future. So minus 1 times minus 3 is 3 17ths, and 2 times 7 is 14. 3 plus 14, 17 17. So that's 1, you see? And this should be zeros. I'll let you to check that. So that's indeed the inverse matrix. So this times this give me the 1 1 1 0 0 0 0 0 has what we wanted. Okay, so that's cofactors. Now you have quizzes and homeworks. So okay, guys, so I'll let you start your homework. Thank you very much for watching the video.